Hello, everyone. A very good evening to one and all present here. Hope you all are doing well. I'm Akshat Walian, and I will be a virtual host for this session, elevating the level of our hackathon that has the legacy of successful triumphs. We feel proud and honored to be the flag bearers of hackCBS 3.0 this year by hosting it in a digitalized way. And we hope that you all are enjoying our hackathon at its best. To make the most out of this time and to help channelize the talent and energy of our beloved developers community, we are organizing a bunch of workshops and qualitative speaker sessions at HackCVS 3.0 this year, out of which many amazing workshops are already being conducted. If you missed any of them, no worries at all. You can go through all the sessions and workshops on our official YouTube channel, HackCBS. And now, here we are live with one more informative and amazing session. For more details about the speaker session, schedule, or any query or question related to HackCBS, you can check our website www.hackcbs.tech. We hope to make these sessions as much as knowledgeable and insightful for you all so that you are geared up to build your hack by collaboration and contribution. Thus, let's get started with our today's session. Today's session is on next level user interfaces with Speechly. This session will guide you through building awesome user interfaces that use voice as an input channel. This means that if you stream audio, then at the same time you will be getting results from the API. With that being said, I would like to introduce to you the speaker of this session, Ottomatias Peura. Ottomatias is working as the head of growth at Speechly. Speechly was founded on the fundamental belief that the voice will be the next big paradigm shift towards following the touch. Around 2016, Speechly realized that the foundational technologies enabling modern user voice interfaces had finally reached a level where something unique could be built. I, on behalf of our dear audience and organizing team, welcome you all, Automatias, and look forward to having a great interaction with you. The virtual stage is all yours. Thank you very much.
Thank you, Akshit, and thanks for the introduction, and welcome from my side, everyone. Let me start by sharing the screen. Okay, so like I said, I'm Ottomatias from Speechly. I'm the head of growth and head of also our developer products, and we are building developer tools for next generation voice user interfaces, or rather developer tools for next generation user interfaces altogether. My background is in startups, but also in politics. I work for Leadfeeder, one of the fastest growing SaaS startups in Finland. Also worked for Bedit, later acquired by Apple, and also as a special advisor for a minister here in Finland. So let's start. Like Akshit introduced, we think kind of the big paradigm shift for the user interface is being pretty close. So we started, or human-computer interaction started in the 1980s. We had typing and these black screens with terminal windows. And that was the first, or not maybe even the first. We had these punch cards even before that, but that was the first more intuitive user interface. Later on, in the 1990s, started the point-and-click paradigm shift in user interfaces, and Windows and Apple's first graphical user interfaces appeared. In the 2000s, we started using mobile phones, especially Nokia's back then, me as a Finn being very proud of those. And that also changed a lot the way how we think of computers, how we use those, and what kind of things can we do with our computers. But infamously, here in Finland at least, Apple did the next paradigm shift with their touch user interfaces. So the big thing that Apple actually did was not the technology itself, kind of like the 3Gs and app stores and all those, but why Apple kind of beat Nokia and all the other old providers was their very intuitive and well-working user interface. And we believe that speech, as the most natural way for humans to communicate, should also be a part of the human computer interaction. We believe that speech should be a part of the touch user interface. So kind of like having the old or 10 years, 15 years old touch user interface accompanied by voice user interface, or completed by a voice user interface. We also believe that this paradigm shift needs easy enough developer tools so that every developer could be a voice developer. They should be able to bring voice to their application. So I think a lot of you have already used smart speakers and voice assistants. Actually, 1/3 of US population is already using smart speakers. In China, more than 70% of people are using voice features in their mobile phones. But we believe that this kind of voice assistant paradigm or voice assistant use case can only solve a small subset of relevant end user problems. Those are mostly related to question-answer based queries or simple commands, so such as turn off the lights, or what's the weather, or play this song. It works great for that kind of use case, but that's only a part. We believe that voice should rather be real-time and multimodal. So when you say to your smart speaker something like, what's the weather, they start speaking the answer back to you. So it's only like one modality is mostly used there, so voice. And even though voice is very, very natural and very powerful way of communicating, it also has its drawbacks. So it's actually pretty slow for getting more information. So if you want to for example, know the 10 biggest cities in India, for example, and you ask that from a smart speaker, it actually takes quite a lot of time when the machine tells you all the big cities, and you can't go easily back and forth. So if you didn't quite get the third biggest city, you have to start the whole experience from scratch again. If you want to repeat that. So it would be actually a lot more easy to see it in a simple, nice list. So that's the multimodality. So not only voice, but also the vision as a modality and touch. So using all of these modalities. We think that's the way how modern user interfaces can actually become more intuitive and more easy and fun to use, just like what iPhone did for mobile phones back in 2010. So for us, the key features for this kind of new paradigm shift is the real-time visual feedback. Speech recognition is already pretty close to human parity in the accuracy. So the transcribing works almost as good as how we humans hear each other. That's not how it feels like, though. So if you have used these systems, you probably know that they fail sometimes, and we humans also fail when we're listening to each other. We don't necessarily hear every word just correct. But because we give this real-time visual feedback, so we nod and say that, yeah, and we might ask, sorry, I didn't get that one. So we give feedback, and we think that the problem of voice currently is the lack of this feedback. And even if we get feedback from smart speakers, we get interruptive feedback. So the smart speaker starts speaking something like, sorry, I didn't understand. Or my favorite example at home, I'm using Google Home. I like Google Home, so not bashing the competitors there. But sometimes when I say, okay, Google Lights, it hears me saying, okay, Google Flights. And then it starts telling me some popular flight destinations from Finland include this and this and this. And then it interrupts me. So I can't just say or like easily fix it, but I have to kind of like start the whole experience from scratch because it's interruptive. On the other hand, visual feedback, so something happening on your screen when you speak, that's not interruptive. So you can speak and you can see things happening on your mobile phone, and even if that goes wrong, it doesn't kind of cut you out. It doesn't interrupt you, and it doesn't put you off, so to say. So we believe that this is the real key. So real-time visual feedback. When you speak, things happen on your screen, and that enables kind of like two things. One, if something goes wrong, you see it clearly and easily and not painfully. And if everything goes well, you are encouraged to continue. So let's say you say something like, "Show me red T-shirts," and then you see already red T-shirts. You're encouraged to keep on with your voice experience. So you can say something like in color or in size large, and show me the most expensive one first, or something like that. So kind of like the key there, just like with human to human in conversations, is that when we give this feedback, we're encouraged to go on, or it's easy for us to fix the problems that might happen. Speechly is built from the ground up to support this kind of multimodality, and on the other hand, we are real time, so that unlike the smart speaker systems where you first say something, then the machine processes your input, and then it gives you the answer. But in Speechly, when you start speaking, you immediately start getting the results back from the API. Speechly is also easy to configure and integrate. So we have a simple Speechly annotation language syntax that you can use to annotate your example utterances that the end users are using, and configure your application by that. That makes it applicable to kind of any domain or industry. We also have ready-made client libraries for easy integration for React, JavaScript, iOS, and whatnot. So some examples on how this can be used and where it can be used. Online grocery is a great example for voice, because people using these grocery or like shopping groceries, they already know what they're looking for. Voice doesn't work, or voice is not the kind of best solution for all the use cases. That's why we believe in multimodality. But voice is a great option for certain use cases. And for example, if you, let's say you have a grocery shopping app and you want to add milk, bread, honey, beer, water to your shopping list, the current experience goes that you go to the search box, you type, then you select something, then you go back to the search, you write something, you select, you go back to the search, you type, you select. And it's pretty tedious. And with the touchscreens and small displays, typing is pretty error prone and slow. Actually, voice is up to three times faster than typing on a mobile phone screen. So that's a great use case. Now, sorry for a small interruption. I have to show this example in another window. So let me see. Like so. So here is a demo of our voice-enabled shopping basket.
Baked beans, cornflakes, brown sauce, Kit Kats, lactose-free cheddar, Bombay Bad Boy pot noodles, Ben & Jerry's cookie dough ice cream, 3 liters of orange juice, 2 packs of toilet paper, and we'll go with the Tropicana orange juice.
Okay, I'm not 100% sure whether you can hear the audio because of some slight technical difficulties with the setup, but anyway, hopefully you could see at least that the end users just starts uttering the things that they need, and they can either use just beer or water, or they can say also the quantities, so 3 liters of milk or something like that. If they have a problem, so if they want to change the product into something else than the first option, they can click on the product and select from a list after that. They can also, of course, use voice to refine the item even more, and they can delete the items either by using voice or by swiping the products off from the list. You can actually find the grocery example from our YouTube channel. So that would be the best option to see it with the audio and all of this if it had some issues. So grocery, one example. Another example, flight booking. So almost all applications have some kind of forms. These forms are also error prone for typing, especially with something like date pickers, because the date pickers are kind of like non-standard in HTML, especially. It's the end user experience is a bit jarring. It depends a bit on how the designer has made it, and you often get this kind of like scrolling back and forth when you click on certain fields, and then you get the keyboard and whatnot. But with voice, it's actually pretty easy to use these forms, because like you probably understood with the smart speakers, one issue with the smart speakers is that when you say "Okay, Google" or Alexa or Siri or whatnot, it just blinks the machine, and it kind of like gives you this impression that it can answer to any problem. It can do everything, but that's not the case. Like you know. So and there is this kind of like problem with the skill discovery, so that you don't know what happens with the smart speaker. But form is a great example of voice not having this skill discovery problem, because when you see the form, you know what kind of like questions you should answer. So let's see another example. Let me see. So here, this is a short video again. So a flight booking form, and as you can see, it has all this typical from, to, depart, whatnot, and then a microphone button. And the form gives clue on what the user should be saying.
Book a round-trip flight from New York to London, departing tomorrow and returning on Sunday, for 3 people in economy class.
And as you can see, it updated once the user said something like New York, it updated it immediately here to London, departing. And if they would have had some kind of an issue, so not 3 people, but they would have actually wanted 4, they can either click here and get the traditional drop-down user interface, or they can just say something like, sorry, I mean for 4 people, and then go on from there. So that was another example. Good. So here again, the multimodality and the real timeliness. So the user gets feedback as they speak, and it's easier for them to understand whether they are understood correctly or whether they need to fix something either by voice or touch. A third example, and this I think we tried a bit earlier, so this had even bigger issues. So hopefully you guys will see how it works. But this demo is also available, or I can share the link somewhere so that you can try it out by yourself. But search filtering is a good example also for voice. So all kind of e-commerce applications and search kind of engines that exist, and most applications have these. are actually, these are often the most kind of like or one of the most important screens in the application. They have a huge effect on conversion rates, and that's why people are using technology such as Algolia, great technology by the way, for improving the search experience and making it faster. And there are data points showing that kind of improving the search by 500 milliseconds or something can improve the conversion rates in an e-commerce shop by 10% or something. So search and good search is a very, very central function in a lot of applications. But how could this be done, say 10 times better? And we think the solution is voice again. And let me try to show you the example. Okay. So giving the microphone access. Show me women's shoes in red and show the most expensive one first. Like so. Again, it's updating in real time for fast and intuitive feedback. And if the user wants, they can, of course, like refine the search even more by using the touch interface, or refine it more by using voice. Let's continue again. So the user can talk to change the filters, and this makes the search actually faster by seconds, not milliseconds. Great use case for voice. So some examples where you should be using voice. There are, of course, many good use cases, but adding items to a list, so the grocery shopping example. But there are a lot more of these. So it could be something like expense tracking. So you can say something like add $200 expense for last Friday in category restaurant, for example. So it's a tedious task with a lot of context switching, so meaning that you have to go to input boxes and different input boxes and touch and type and whatnot. But with voice, it's very intuitive. Form filling, a bit related to the previous example, but here meaning a bit more like the search filtering example that I showed, or the booking form. It could also be something like doctor's appointment or some professional service kind of form. It's fast and intuitive because you see the form and the filters. And one good part of voice is actually also that you don't have to specify the words that the user is using, the words previously. So with traditional user interface, you have to have all the features that you have to have a button for those. So let's say you could use words such as shoes or footwear. So in a traditional user interface, you have to choose one of these. And for users who are looking for shoes, if you have picked footwear, they might not find it as easily as they could. But with voice, you can actually use synonyms. So it's a good like feature in form filling as well. Third example being quick navigation that I already a bit mentioned about here. So the features being available from all screens. So let's say Facebook application or Twitter or something. You're scrolling endlessly the list of posts, and then you realize that, okay, now I need to change my profile picture. It's such an old picture. And traditionally, you have to go to some kind of a hamburger icon, maybe find your profile settings there, and then scroll and search, and then from somewhere you find the picture, and then you can change it. But with voice, you could actually just have a microphone button and say something like change my profile picture, and you would immediately be presented with the correct screen. This quick navigation can also be thought as some kind of like broader terms. So it can also be all kind of command and control kind of use cases. So you can say something like play next song or turn off the lights, as in a very traditional smart speaker kind of way. But as I said, this is only a small subset. Then there's also the professional services, meaning warehousing, maintenance, where the kind of like words that the people are using are very specific and known to all the end users. That's also a good example or good use case for voice, as it's a lot faster and more efficient than using touching and typing. Also, some other use cases, including hands-free situations. So, for example, breastfeeding and driving, customer support, all kind of devices and domestic appliances. So of course, the smart speakers as well. Point of sales is a very interesting use case. Like thinking of the current COVID situation, for instance, if you're using, or if a restaurant is using these screens where you can select the item that you want to order. Those are not probably the thing currently with this situation, but what if you could use voice to do the same? So going to a hamburger chain and say something like, I want 2 cheeseburgers with fries and mayo and with Coke and Sprite, for instance. Or financial services such as the expense tracking that I already mentioned, or use cases such as send $200 to Bill or something like that. You can probably, or I hope that in the hackathon as well, you can find even more good use cases for voice. How to get started with Speechly. So first part is configuring the voice application. In Speechly, it happens by providing our system a set of example utterances that the end users are saying. So these kind of that I showed in the example. So show me red t-shirts in size large and whatnot, or show me or book me a flight from London to New York. So you provide the system with example utterances, and then you can use our SAL Speechly annotation language syntax to kind of like tag those utterances. Then you deploy the model, it trains for a while, and there is actually some machine learning magic happening. So you don't need to type all the possible utterances, but just provide it with some examples. Then after it's deployed, you can try it out in our web tool and see yourself how the speech recognition and the intent entity tagging is working. Once you're happy with that, you can start integrating it to your application by using our React or JavaScript integrations and ready-made microphone components. Once you're happy with your first kind of like proof of concept or a demo, you should be testing it out with your friends and colleagues, and of course in the end with end users as well, and then iterate. When you do any changes for the Speechly model, it will automatically be propagated to all clients, so it's immediately accessible by all devices that are using your or all the instances of your application, so to say. You can even use the same model in all like different applications. So you can use the same model in web and in iOS and Android for easy kind of like a consistent user experience. So happy hacking. We are a gold partner here at the hackCBS. We are providing 4 gift cards for the best 3 teams using our technology. And this can be combined to other custom prizes in hackCBS. So if you're interested in some other cool custom prize pools that seem to exist, for instance, I remember at least there being one cryptocurrency thing. You could actually use also the voice user interface and kind of like participate in 2. So hopefully you guys will be interested in trying out our technology and be eligible for winning these prizes. We also have a special offer for all the hackathon participants, so you can use our technology for free for all kind of non-commercial applications and get a free one-on-one training for using our technology. We also, of course, support you during the hackathon in the discourse channel. Here are some resources. You should be able to find this easily by using Google as well, but just to remind you what we have. So there's the Speechly website, our documentation. We have a YouTube channel that I already kind of like teased you with some examples. There are quick start guides, example configurations. There's our GitHub repository with all the client SDKs and client libraries and some example applications. Then the dashboard that I mentioned for configuring your application can be found through api.speechly.com. And like mentioned, we also support you during the hackathon in the Speechly at hackCBS channel. Okay, thank you. I'm not fully aware if you can ask any questions, but if you do have some, yes, you do have some questions here. Yes, so there's a question, how to convert text to speech from Speechly. You can use Speechly for only kind of like text to speech purposes, but as we are mostly like user interface tool, that's not the best use case for Speechly. But there is a React tutorial available in our documentation, and that following that you will get pretty easily like an understanding on how React can be used to do that. You can also find the packages in NPM. Unfortunately, you can't use it in Android Studio just yet. We have the Android client library ready, I hope, in about 1.5 months or so. Okay, there's also one question about the quality for like children and adults. We don't differentiate that automatically, but the technology is, or the data that we have used for training the models does include all kinds of voices, so it should work with all kinds of people. But of course, if there's like, again, it's meant for user interfaces, so if there's kind of like conversation going on in the background, it might have some problems. For React, yes, there is. You should find the React tutorial for instructions on how to download it with npm and integrating into your application. Let me see if I can see another good question here. Yes. Okay, and yeah, like mentioned, if you have any questions, any further questions, please come to our hackCBS channel in Discourse, and we will be answering the more technical questions there. Thanks.
Thank you very much, Ottomatias, for enlightening us with your knowledge and experience and delivering us such an informative session. Thanks to our audience as well. And as Ottomatias has already informed that you can get a chance to win Amazon coupons worth $50 for you if you will use Speechly in your project. For more details, you can join Speechly at hackCBS channel in our Discord server, and you can also ask your queries in the same channel. Besides this, we request you all to fill the feedback form of this session to get the certificates for this session, and link to the feedback form will be dropped in the chat window and the description. We are having our next workshop, which will be the last workshop of hackCBS edition 3.0, tomorrow in the morning at 10 a.m. on Introduction to Amazon Web Services, which will be taken by Angelina Shin, who is AWS Educate Student Ambassador. So let's connect at 10 a.m. tomorrow for one more great session. Hope to see you all there. And for now, we are having an amazing fun event for you all. I request you to join the MLH Werewolf Lounge in our Discord server and take a break from your hacking. Thank you very much, everyone, for joining, and have a nice day.
Thank you.